Hey guys, this is Miss Dam, and today we are going to talk about forces. First off, let's start with the definition of force. A force is a push or pull that can change the motion of an object. And when we talk about forces, there are some different types of forces. One of these can be balanced forces. This is when our forces are equal in size and opposite in direction. The result is no motion. And something I want you to write is no change in motion. We can actually have balanced forces that are moving, but they're moving at a constant speed. They're not changing direction and they're not changing speed. A second type of force is an unbalanced force. This is where our forces are unequal in size and they result in motion. What I want you to write here is change in motion. So when we talk about forces, forces are energy that is applied to an object causing motion. If you think about standing behind someone who's on a swing, you apply energy as you push that person and it causes motion. So you apply that force and the result is motion. The next thing we're going to talk about is something called work. Work is done when a force acts upon an object and moves it out of its place over a distance. The important word here is distance. You must move something a distance for work to be done. My example that I think of is a pickle jar. Think of someone trying to open a pickle jar and it won't budge. They try and try, they apply a lot of force, try as hard as they can, and that lid does not move. Well, then they hand it to the next person. Next person comes up and they apply a force and twist it right off. The lid moves. Usually the joke is I loosened it up for you. But person one, they did no work. They didn't move the pickle jar, the lid. Person two did move it, so they did work. All right, so there is a math formula for work, and it is work equals force times distance. What I want you to write is W equals F times D. Don't forget to use your formula triangle when you set up these problems. And here is our formula triangle. We have W on top, so W right here on top, F and D on the bottom. And remember, top and bottom divide, side by side multiply. So you can use this triangle, the formula triangle, to solve math problems that have to do with work, just like you've done for the FMA problems and the STD problems. All right, now if you'll go ahead and turn the page to the science challenge, we can put what we just took notes on to use. All right, you should all be on this page. Let's start with the reading. Maria, David, and Carlos are helping their dad clean the garage. Their dad wants 3 boxes stored on a shelf that is 1 meter above the floor. All 3 boxes are the same size and have the same mass. Maria uses 50 newtons of force to lift the first box 1 meter to the shelf. David uses 10 newtons of force and a 5-meter ramp to push the second box to the shelf. He's working smarter, not harder. Carlos decided to use the ramp too, but the third box doesn't move when he pushes against it, only using a force of 2 newtons. His doesn't move, so his distance is 0. Now let's look at number 1. Add force and distance values to illustrate the motions for each box in the spaces below. Arrows are used to represent force. So what they're asking is for us to add the force and distance to the picture. Where the arrow is, we're going to add force, and where the bracket is, we're going to add distance. So let's look at these arrows. The longer the arrow, the greater the force. Notice Maria's is a longer arrow because she used a force of 50, while Carlos only used 2, and his force is much shorter with the arrow. All right, so Maria had a force of 50 newtons, so we're going to add in 50 newtons by her arrow. And she lifted that box a distance of 1 meter. She just picked it right up for the shelf. David, on the other hand, used a force of 10 newtons, and he moved the box up a 5-meter ramp. Carlos used a force of 2 newtons, and it didn't move, so his distance was 0 meters. Make sure you have these distances recorded. For number 1, I'm going to get you started on numbers 2, 3, and 4, and then let you do the work on those. We'll do part 1 of number 2 together. This says, in the boxes below, begin writing the formula for work and then show work calculations for the motion of each box. Make sure you use your formula triangle on each of these problems. So we have our formula triangle, and Maria, we are trying to solve for the amount of work she did. Now if we look at our picture, we know that she used a force of 50 newtons, and she moved her box a distance of 1 meter. Now my question for you is, do we multiply or divide? Well, I'm hoping somebody said side by side, multiply. So we're going to take 50 newtons and multiply it by 1 meter. 50 times 1 is 50. And we have 50 newton meters, or 50 joules, which is shown with a J. That's what it's represented by. Work is measured in joules. Teachers, if you will please pause the video now to let the students solve the next 2 problems for work, making sure that they use their formula triangle. Okay, you should have received or found these answers. David, he used a force of 10 newtons over a distance of 5 meters. 10 times 5 is 50, so he also had 50 joules for his amount of work. And then Carlos, he had a force of 2 newtons over a distance of 0 meters. 2 times 0 is 0, so Carlos had 0 joules for his work. Let's move on to number 3. If you look here at number 3, David and Maria did the same amount of work. They both did 50 newtons. Compared to Maria, what variable increased when David performed work on the box, and what variable decreased when David performed work on the box? What you're going to do on this problem is decide which variable changed, and the variables they're talking about are force and distance. You'll look at your math problems and see which ones changed. And then for number 4, although Carlos applied force to the box, no work was done. Use the work formula to explain why. Remember the work formula? Work equals force times distance, and he did not move the box. His distance was 0. Go ahead and finish these problems. Great job.